Can you feel the excitement? We're going to solve a differential equation by using Laplace transforms. Who knew that this could be done? So the main thing to do here is notice that we have initial conditions. So we're just going to flow along with the problem to see how they fall into place here. We're going to take the Laplace transform of both sides because we know that every derivative of y can be written in terms of y when it comes to the Laplace transform. So I'm going to say that we have the Laplace transform of y double prime minus 2 times the Laplace transform of y prime minus 8 times the Laplace transform of y equals the Laplace transform of 0. Well, I'll do the hard part first. The Laplace transform of 0 is 0. So there we go. So the Laplace transform of y double prime. Now we're going to make a notation here. We're going to say that the Laplace transform of y is equal to big Y of s. So Laplace transform of y double prime is s squared y of s minus s times y at 0 minus y prime at 0. This is all the Laplace transform of y double prime. So minus 2, now the Laplace transform of y prime is equal to, I'm just going to put that in here, is s times y of s minus y at 0. And then minus 8, now the Laplace transform of y, we're just calling y of s. So sit back and look at that, and what you notice is we now have an algebraic equation for y of s. So the next logical thing to do here is to substitute what I know and solve. Now we know that y at 0 is equal to 2. So everywhere we see a y at 0, we're going to replace it with a 2. And we know that y prime at 0 is 3, which means everywhere we see a y prime at 0, we're going to replace it with a 3. So we have s squared y of s minus y of 0 is 2, so this is 2s minus 3 minus 2s y of s. Now we're going to have plus 2 y at 0, so that's going to be plus 4, and then minus 8 y of s equals 0. So we're going to solve this for y of s. So I'm going to keep all the y of s terms to one side. I'm going to move all of the non-y of s terms to the other side. So you notice there's a negative 2s there, so that's going to be positive 2s over here. Minus 3 plus 4 over on the left-hand side is plus 1, so that's going to be minus 1. And you notice it's coming together. We can factor out a y of s. And wouldn't you know, we have 2s minus 1 over s squared minus 2s minus 8. So we have solved for the transform of y. Well, we know that if we know the transform of y, we can find what y is. So we are just steps away from finding y of t, which was the goal of solving a differential equation. So we know we're going to need partial fractions here. The factors are, lo and behold, s minus 4 and s plus 2. So this is sum a over s minus 4 plus sum b over s plus 2. And I know I multiplied both sides by the LCD to clear the fraction out to make this easier to work out. And we substitute values of s. That seems to be the easiest way to go. So I'm going to say s equals negative 2. The left-hand side would give me negative 5. The a term would drop out, and I get negative 6b. So it looks like b is equal to 6. I'm sorry, not 6/5. Oh, algebra. 5/6. And then if s is equal to 4, left-hand side looks like 7. We have 4 plus 2 times a, which is 6a, and the b term drops out. So we have a is equal to 7 over 6. So that means that y of s is equal to 7/6 over s minus 4 plus 5/6 over s plus 2. And now we can easily go back to y of t because those are just exponentials. Something over s minus 4 transforms back to e to the 4t. And 1 over s plus 2 transforms back to e to the negative 2t. And that is the inverse function. That is also the solution to the original differential equation. So think about what we've done in the past. We had to find the homogeneous solution, right? C1e to the blah plus C2e to the blah. And then we had to apply initial conditions to find C1 and C2. With Laplace transforms, all we had to do was Laplace both sides, and the initial conditions are already figured in. So that work was done for us. All that we had to do was find an inverse transform. So maybe this is easier. With non-homogeneous equations, it's going to be a lot easier. So we definitely have more ground to cover here. So hopefully this was exciting for you as it was for me. Come back and watch more videos later. Thanks so much.